Okay, time for part 2 of this lesson on linear equations. And this one, we're going to focus on x and y intercepts. And x and y intercepts, we already talked about y-intercept and what that is in our slope y-intercept formula. The b part of the equation is where the line crosses the y-axis. So the x-intercept is where the line crosses the x-axis. So we have x-intercepts and y-intercepts for linear graphs. And we can find them pretty easily by looking at a graph because we just want to look at where they cross. So our x-intercept for this line is where it crosses the x-axis, which is -3, 0. The y-intercept is where it crosses the y-axis, which is 0, 4. Okay, x-intercepts also have some other names. They are sometimes referred to as a root of the equation, or a root of the quadratic, or whatever the case may be if it's a quadratic equation, a zero, or a solution to the equation. Okay, so if you hear the words root, zero, and solution when we're talking about equations, those are referring to x-intercepts. To find the x and y-intercept, the thing we really want to keep in mind is that when we're looking at an x-intercept where it crosses the x-axis, all of the points along that line have a y equation of 0. Okay, so if we set y equal to 0, it will give us the x-intercept. So let's do that for this equation right here. Y equals -2x plus 5. We set y equal to 0. So 0 equals -2x plus 5. What is the x that makes y equal to 0? Solve for x using inverse operations and working backwards. So add 2x to both sides, divide by 2. X is 5/2. That's our x-intercepts. That's where it's going to cross the x-axis. That's also 2.5. Okay, so positive 2.5. The y-intercept, where it crosses the y-axis, is the opposite. So all along this y-axis, our x-coordinate is 0. So if we set x equal to 0 in an equation, it will give us the y-intercept. So you're always setting the opposite variable equal to 0. So for this one, to find the y-intercept, we're going to plug in 0 for x. So we do y equals -2 times 0 plus 5, and then solve for y. So 0 plus 5, when we take -2 times 0, which means y equals 5. So that's our y-intercept. Now, this is super, super important. We have an x and we have a y, but these are two different points. Remember, we got these 2 points by setting y equal to 0 and setting x equal to 0. So it's not the point 5/2 or 2.5 comma 5. It is 2 points, and those 2 points are 5/2, 0, or 2.5, 0, and 0, 5. One on the x-axis, one on the y-axis. That is the most common mistake that I see when we're working with x-y intercepts, is to put those two numbers together and make it 1 point and then kind of go like, well, now how do I graph a line? All I have is 1 point. You have 2. All right, so all of our practice problems today deal with finding the x and y intercept and then graphing the equation. So let's dive right in. These first 2 problems are fairly similar. We're going to start with y equals -5x minus 1. We're going to find the x-intercept by setting y equal to 0. So y becomes 0. Solve for x. So add 1 to both sides, divide both sides by 5. 1/5 is x. So that's the point, 1/5, 0. This graph, these aren't going to be perfect points for these graphs. So just do your best. You could change the scale, but it's not super important as long as your graph is pretty much close to being accurate. So put that point between 0 and 1 closer to 0, okay? Now, to find the y-intercept, we're going to set x equal to 0. So that's what you always do. If you can't remember, always set x equal to 0. So we have 5 times 0 minus 1 equals y, which just means 0 minus 1 equals y, which means y is -1. Now, you might be looking at that and thinking -1, -1. And the reason why it comes up like that is because this equation was in slope-intercept form. So we really didn't need to go through these steps right here to get the y-intercept because this equation was in slope-intercept form. So it's telling us the y-intercept from the very beginning. But if you forget and you don't recognize it, it's okay to go through these steps to get the y-intercept. Okay, so that means our y-intercept is 0, -1. So I put that point on my graph, draw the line to connect them, and there we go. That's the equation of y equals 5x minus 1. Okay, now I'll give you a hint here. Number 2 and number 3 both have equations in slope-intercept form. So you can use this trick of just looking at what that b value is to get the y-intercept, but you'll have to go through this process to get the x-intercept, okay? So pause the video, do numbers 2 and 3, and then come back and we will check your work. Okay, let's look at number 2. On number 2, we have y equals -6/5 x plus 2. When you plug 0 in for y and solve for x, you get an x-intercept of 5/3 0, which is right there, okay, 1 2/3. And then you get the y-intercept is right there of 2. So we put that on the line and then we graph that equation. Number 3, y equals -3x plus 16/3. Again, set y equal to 0. So we have 0 equals -3x plus 16/3. You had to do a little bit more tricky math here to get x, but when you go through the steps, you get 1 7/9 or 16/9. You could leave it either way, but 1 7/9 is a little bit easier to think about as far as when we graph it. It's going to be right in between 1 and 2, closer to 2, okay? And again, that's my y-intercept. So my y-intercept is 16/3. What is that? That is 5 1/3. So y-intercept of 5 1/3 is up here, and then graph that line by connecting the dots. Okay, we're going to do the next one together, number 4. On number 4, we have an equation. This one is not in slope-intercept form. It is in standard form. And there's also a little bit of a shortcut when we're in standard form, and I will show it to you after we work through this process once. Okay, so 4x minus y equals 8. To find the x-intercept, we're going to substitute 0 in for y. That just makes that one go away. So we get 4x minus 0 is just 4x, which is equal to 8. Divide by 4 and x equals 2. So we plot that point for our line at 2, 0. And for our y-intercept, we do the opposite. We're going to plug 0 in for x. 4 times 0 becomes 0. And 0 minus y is just -y. And when -y equals 8, when y is negative, when you have a negative variable equal to a number, you just take and flip both of their signs. So the y becomes positive, the 8 becomes negative, y equals -8, which means this point is at 0, -8. Now we can connect the dots and we have our line. Now, let me show you the trick. When you look at an equation like this and you have an equation in standard form where you have something times y or something times x, and either the y or something times y equals another number. When you're looking for intercepts, you can really just ignore instead of plugging in 0. So instead of sticking a 0 in here, what I can do is I know if I put 0 in that this entire term is going to just go away. And so I just think about it as that I'm going to use the cover up method is what it's called. I'm going to cover up that piece of the equation with the tip of my pencil or your finger or whatever you want to put there, and look at what's left. So we have 4x equals 8, solve for x by dividing both sides by 4. And then when we go to find the y-intercept, we do the same thing. We just cover up the x part of the equation, not the sign in front of y, because that's important, okay? So that's the cover up method. You may remember that from Algebra 1 when you worked on solving for intercepts. So you can use that method anytime you have an equation in standard form. Sometimes it works better than others, but if you use that like on number 5, you can cover up this y part of the equation and the sign that's in front of it. You're gonna, to find your x-intercept, you're just gonna have negative 5x equals negative 24 and solve for x. It's not gonna come out perfect, that's okay. To solve for the y-intercept, you're gonna cover up the x part of the equation. And you always want the variable that is the intercept you're looking for. Okay, so that means you have these 3 left. Well, I want you to do number 5 real quick. Pause the video, come back, check that answer, and then we'll do number 6 together, and then I'll let you do number 7, because 6 and 7 deal with some fractions, and I just want to remind you of some steps there. So go ahead and do number 5 if you haven't. All right, let's take a look at your answer for number 5. So for number 5, your x-intercept is 4 4/5. That 24 divided by 5, 24/5 is 4 4/5. And then for the other one, it was 24 divided by 4, which is 6. So that was at 6, 0, 6. Draw the line to connect those points. Okay. Number 6 has some fractions. So let's review some work with fractions here. We'll pull this up. 3/4 x minus 1/3 y equals -2. So this is standard form. So I'm going to do that thing that I was just talking about. I'm going to ignore this piece of the equation. So I'm just going to write for my x-intercept, 3/4 x equals -2. That's what's left when this goes away. And then to isolate x, when you have a fraction times a variable, you multiply both sides of your equation by the reciprocal of your coefficient. So your coefficient is 3/4, its reciprocal is 4/3. So we take both sides of our equations times 4/3. Over here, those cancel out completely. And over here, you want to think about this as like 2/1 times 4/3, which gives us -8/3. That could also be written as -2 2/3 as the mixed number. So we're going to plot that on our graph. Now let's look at y. So for the y-intercept, we ignore the x part of the equation. So I'm just going to copy that, and we get -1/3 y equals -2. Again, multiply both sides by the reciprocal. The reciprocal of the fraction -1/3 is -3, or 3/1. So then this goes away. On the other side, we get 6. And when we plot the 6 on the y-axis, it's way up here. And then we connect our dots. Okay, so hopefully you remember how to do that. Pause, do number 7, come back and check your answer. Okay, let's see how you did for number 7. You should have gotten an x-intercept of 2 2/5, 0. That's between 2 and 3. And for the y-intercept, you get 7 1/5. So way up just past the point 7 on the y-axis. Connect the dots, and there you go. All right, so that's linear equations, linear relations. Let me know if you have any questions. If you didn't get any of those and you can't figure out what you did wrong, please reach out to me and let me know. Otherwise, that's it for this particular lesson.